limiting reaction problems, some prerequisites you need to know for this are stoichiometry involving volume, mass to mass calculations, mole to mole calculations, and balancing equations. Alright, to explain what the limiting reactant is, it is the reactant that gets consumed first in a chemical reaction, therefore limits how much product can be formed. As in, if you have 20 grams of one substance and 15 grams of the other, and they're 1-to-1 mole ratio, or I guess one better way to put it would be, if you have 1 mole of an element and you have 2 moles of an element, only 1 mole, if in the equation it's 1-to-1, only 1 mole will react for both, and then if the one that has 2 moles, the extra mole won't react at all. And this is called a limiting reactant because it can't react because the other reactant doesn't have enough. So here's an example of it. If that 1-to-1 ratio is 1 square to 1 square, and they react to form XY, that would be good reaction, good reaction, good reaction. And as you can see here, this one is limiting this one because since there's not a fourth one, it's stuck in this position. And so it got limited by Y because it can't form any more because there's no more red. And that means that Y is the limiting reactant. And so it's always what's going to be the smaller number, the smaller amount of overall number is what's going to be limiting reactant. All right, let's get into an example. So if 125 grams of P4 and 384 grams of Cl2, which one is the limiting reactant? And so what we're going to do here is we're going to start off with trying to find which one we have less of in the equation. And so we're going to have our givens. We're going to start with our givens, right? We have 2 equations for each one of these givens. So if they're givens, divide by molar mass. So this mole, or 4 P's, weighs 123, and so on. Once we have molar mass, we're going to find the ratio, as we are trying to find how much product they can form. So we're using the given to find how much product they can form. And then so once we got how many moles we have, then we're going to times by the final molar mass of this. And we are going to end up with how much of 125 grams could make versus how much of 384 grams of Cl can make. And as you can see, the Cl makes less. That means it's a limiting reactant, meaning since it makes less of the product, there's less reactant compared to this because it makes more of the product. And so this is going to be limiting reactant, because if these two were to form together, that extra 58 grams that this one made wouldn't be made because there's no more of Cl to react with it to get to there. Alright, and as you can see, since Cl produces less product as a limiting reactant, the amount of product it produces and then on a side note, these are all theoretical yields saying if the whole equation was 100% successful, as in every single molecule reacted perfectly, it would form that many amount of grams. Alright, for problem number 1, if 90 grams of FeCl3 reacts with 52.0 grams H2S, what reactant is the limiting reactant? So we have our 2 givens and mass, and we're gonna see some of the last time what is, which one would produce more. So if you solved it correctly, it should look like 90 grams, 52 grams you're given, you divide by molar mass to find how many moles, use the mole ratio if you write out the balance equation, and then times by molar mass of the product and figure out how much of for 90 grams of FeCl3 it makes 60.8, and 52 H2S it makes 111, meaning that this one makes less, meaning that if these two were to react together, it would only make this much, and so it would limit this. So this is limiting reactant. So the answer is FeCl3 because of that. Alright, and then number 3, how many grams of barium sulfate sulfate will be formed from 200 grams of barium nitrate and 150 grams of sodium sulfate. What is the limiting reactant? So we have our two givens, and we're gonna first write out our balance equation, and then we're gonna start our equations with our 200 grams of BaNO3, 150 grams of NaOSO4, and we're gonna convert this into one of these, and we're going to see which one more can make. So we're going to divide by mole mass to find moles, use the mole ratio, and for this example, we'll be using BaSO4. You could also use 2NaO3 if you wanted. It still shows which one it makes less of. As you can see, this one makes less, meaning that if these two were to react, it would only make 178, and all the extra grams that this can produce of NaSO4 would be not used. Therefore, the limiting reactant is BaNO3 too. Alright, for the third problem, once again, try to solve this on your own, but I'll walk through it now. How many grams of silver bromide AgBr can be formed when solutions containing 50 grams of MgBr2 and 100.0 grams of AgNO3 are mixed together? What is the limiting reactant? Alright, so we have our two givens, and we're gonna, balance first find our equation. That way you can find the mole ratio. But then we're gonna use our givens, divide by molar mass to get into moles. And these could be given in liters, they could be given represented particles. All that matters is that you get to moles. And once you have it in moles, convert it into how much of AgBr it would make using molar mass. And we figure out that this one makes 102 and this one makes 110.5, meaning that this one makes less. And so the one that always makes less is the limiting reactant, because it's going to limit this equation to only making this much. So the answer would be MgBr2. Alright.